Hi, everybody. This is Jen, and I'm back with Coins in a Jar problem, Strategy 2, Make a Big Table. As a refresher, our context is we have coins in a jar, and the clues were given for every 2 nickels, there are 3 dimes. For every 2 dimes, there are 5 quarters. And I just remembered the other clue. We have five. Oops, only one E and we. We have 500 total coins. Okay, we need all of our clues. To set up a big table, the first thing I'm going to do is make sure that I have numbers that are useful that I can work with. So I've got 2 nickels and 3 dimes, 2 nickels and 3 dimes, 2 dimes and 5 quarters, 2 dimes and 5 quarters. Just like last time, I can't compare these two ratios because I can't compare a ratio that has 3 dimes with a ratio that has 2 dimes, but I can compare two ratios that both have 6 dimes. So I'm gonna do this. I'm gonna use a scale factor of 2 in my table on the left. So 2 times 2 is 4. And I'm gonna use a scale factor of 3 in my table that's on the right. So 5 times 3 is 15. So just like last time, we now have a ratio, a part to part to part ratio, 4 to 6 to 15, that I can use to solve this problem. We're ready to make our big table. So we're going to make our big table. Our big table is going to have lots of columns. It's going to have nickels. It's going to have dimes. It's going to have quarters. And your sixth grader might stop with nickels, dimes, and quarters, and that's going to work just fine. A pro tip that you could share with them is to also include a column for total coins, which I think is going to become obvious here in a moment, why that's helpful. Okay, let me finish up my table here. If I was doing this in a classroom, the students would be also copying this with me, so silence would not be awkward. But perfect. All right. I can add more rows if I need them. I will say a little aside here. I always encourage my students to write out the whole word in their table and not just represented by a single letter. And the reason is this. Well, there's 2 reasons. Number one, if they do their homework on a Friday and we talk about the problem on a Monday, that's like a million years in 6th grade brain time. So they might have forgotten what they were thinking. Having things written out more clearly will help them remember how they were thinking about a problem when they go to share their thinking with a partner or with the class. The other reason is because it prevents a misconception from developing. And the misconception is this: if they use the letter N, in this case, they would be using it as a unit. So 4N is 4 nickels. But when we go to algebra, it's a variable. So this is 4N means 4 nickels. As a variable, we'd write 4N, and 4N means 4 multiplied by N. That N is a variable standing in place for a value. And so you can see, I hope you can see that this is super confusing. So I try to help kids get away from writing or using single letters as units, with the exception of obvious ones like M for meters, L for liters, things like that. But if it's not a standard unit, if they're making up their own units, I encourage them to write out the whole word. Okay, so nickels, dimes, quarters, total. Nickels is 4, dimes is 6. My pen isn't working. 6. Quarters is 15. And then total for, if I had this number of coins, 4 plus 6 is 10, plus 15 is 25. And we see this 25 crop up again. We saw this number 25 in our tape diagram representation. I really do encourage students to be on the lookout for connections between different representations because we're doing the same problem. We're just looking at it and showing our thinking in different ways. There should be connections between the different representations. And as students are developing their critical thinking skills and noticing skills, they're going to start to notice those connections, and that's going to help them move from the less efficient, more concrete strategies to a medium strategy like this one, and then eventually to a more efficient algebraic strategy because they can see the connections and they can kind of use all of their understanding of all the different ways of thinking about the problem to reason about a problem like this. Cool. All right. So I could do, what's going on here? Right. I have 500 coins total. So I need to get to 500 in my total column. I could do it in one jump. I know the answer because I just did the problem a different way. Let's pretend I haven't done that. To get from 20, I can take it up. I'm trying to go to 500. So I could go to 250 pretty easily by multiplying times 10. And then from there, I just double it to get to 500. That's not the only way to get to 500. You could have done, I don't know if that pen color is showing up. I'm going to change it. You could have done times 20. You could have done times 10 times 2. You could have done it the other way. You could have done it times 2 times 2 and then times 5. Anything that gets you to 500 will work just fine. Okay. But since I did times 10 times 2 in my total column, I need to do the same thing in my other columns. So for nickels, I'm going to do times 10, which is 40. Oh, that color doesn't work. That's a reason. Sorry. 40, and then times 2. 40 times 2 is 80. I'm going to do times 10 times 2 there. I'm going to do times 10 times 2 there. 60. 60 times 2 is 120. 150. 15 times 10 is 150. 150 times 2 is 300. So we see that there are 80 nickels, 120 dimes, and 300 quarters. And that is my answer. Awesome. Cool. If you watched the first video and you saw the first problem, you'll notice that we actually only solved part A of the problem. Part B is, what's this worth? What's the value? What is the value of the coins? This is vaguely trivial, but some sixth graders actually struggle with, because there's decimals involved, because money is decimals. So we're going to do 80 nickels times 0.05, and we're going to do 120 dimes times 0.010. I can do that pretty easily in my head, so that's going to be $12. And then we're going to do 300 times 0.25. And I'm going to go ahead and just pull out a calculator. That's fine. Oh, wait. This is going to be $4. 300 times 0.25 is, what's a quarter of 300? 175? No, 12. I don't know where I got 75. 12. No, that's not right. Yep, I was right the first time. I know that I'm a math teacher, but arithmetic is my nemesis, and my students catch me in arithmetic mistakes all the time, which is awesome because it empowers them and they think they're smarter than me. So that's cool. Add all these up together. I did it the other day. I think it's $91. But yeah. All right. Well, thank you for watching, and I look forward to making more of these videos in the future. If there's a particular representation or a strategy or something that you're seeing in your students' math curriculum that you're not familiar with, put it in the comments, and I can make a video showing you how to use that strategy and why it makes sense for students. Okay, thank you.